10th chapter, Applications of Derivatives. This chapter belongs to Mathematics 1B, part 26. Last part completed. Compulsory one question, 4 marks in IB examination topic, that is rate of change, velocity, acceleration, and the volume of the core and volume of the cube, rate of change of height of the cube, rate of change of height of the cone. That problems model completed, very important repeated problem. 4 marks also be completed. Then that last exercise 10E, compulsory 4 marks question coming to the IB examination. Today class discuss one more topic, next topic. In this topic 90% coming to the 2 marks problem in IB examination. Here what is the topic? Here two theorems is there. One is Rolle's theorem, second one is Lagrange's mean value theorem. What is the meaning of Rolle's theorem? This Rolle's theorem sometimes ask 2 marks. Question asked in this way: state Rolle's theorem. State Rolle's theorem. This is the 2 marks. You can write statement, you get 2 marks. Sometimes ask this Rolle's theorem using problems. That is exercise 10F. First, what is the meaning of Rolle's theorem? First of all, what is the meaning of Rolle's theorem? In this Rolle's theorem, first you can discuss statement. If f of x is any one function, f of x is what, friends? F of x is any one function in the closed interval a comma b. What is the meaning of closed interval? Closed interval nothing but the value. Suppose this is a, this is b, this is closed interval. The value will be 2x. Suppose x belongs to closed interval. Here this means what? The value of x between a and b, including a and b. Between a and b, including a and b. That is called closed interval a comma b. Understood or not? What is the meaning of open interval? What is the meaning of open interval? Open interval a comma b nothing but the value of x lies between a b only. Lies between a b only, not included a b. That is called open interval. That's why here closed interval nothing but the value lies between a b and including a b. Such that here this Rolle's theorem you can satisfy 3 conditions. Rolle's theorem having how many conditions? Statement 3 conditions. One is f of x is continuous. F of x is continuous in closed bracket a comma b. This is the first condition. F of x function compulsory continuous in the interval of a comma b, closed interval. What is the second condition? Second condition, f of x is differentiable in open interval a comma b. In open interval a comma b. In this open interval a comma b, f of x having differentiable. First condition, f of x is continuous. Second condition, f of x is differentiable. First condition, f of x is continuous in closed interval a comma b. Second condition, f of x is differentiable in open interval a comma b. This is the first one. This one is the second one. Third one, if you can find the f of a value, similarly you can find the f of b value. Here a comma b is the interval values. Here a is the lower limit, b is the upper limit. Nothing but a is the minimum value, b is the maximum value. You can write in the function f of x minimum value you get one value. You can write a maximum value, you get another value. These two values are compulsory equal. You can write a lower limit, you get suppose a value is there. You get maximum value, you can write you get same value a. Here f of a value is compulsory equal to f of a. In these 3 conditions can be applicable, then there exists C belongs to a comma b. C belongs to a comma b. Here a comma b is the open interval. In that open interval, C is the any one element such that f dash of C equal to 0. Here, in this f of x is continuous in closed interval a comma b, f of x is differentiable open interval in a comma b, then f of a equal to f of b also be possible, then f dash of c equal to 0 also be possible, f dash of c nothing but the derivative of f of x. You can substitute it in place of x. C here c value belongs to a comma b open interval. Here c value belongs to a comma b open interval only. This Rolle's theorem satisfied. After that, c value does not belong to a comma b. That c value cannot be satisfied in this Rolle's theorem. Understood or not? In this Rolle's theorem, you can ask 2 marks. State Rolle's theorem. You can write first condition, second condition, third condition. Then there exists f dash of c equal to 0. C belongs to a comma b. You can write these 3 conditions. You get 2 marks. Understood or not? Sometimes ask in this model, Rolle's theorem model problems. That problems explained in next class. This is the theorem of the Rolle's theorem statement. Last theorem, Rolle's theorem completed. Next you can discuss Lagrange's mean value theorem. Which theorem? Lagrange's mean value theorem. This theorem you can ask 2 marks problem. State Lagrange's mean value theorem. What is the statement? In this theorem having once again 3 conditions. In this statement, if f of x is a function defined in closed interval a comma b. Last theorem also be f of x is a function is defined in closed interval a comma b. This Lagrange's mean value theorem also be similar way, such that first condition is what? F of x is continuous in closed interval a comma b. Here first of all, that f of x function is defined with closed interval a comma b. That f of x function is continuous in a closed interval a comma b. Second one is f of x is differentiable in open interval a comma b. Similarly, by the Rolle's theorem, first condition is f of x is continuous in closed interval a comma b. In this Lagrange's mean value theorem also, f of x is continuous in closed interval a comma b. Similarly, second condition, here Lagrange's mean value theorem is what? F of x is differentiable in open interval a comma b. In this Rolle's theorem also be second condition, f of x is differentiable in open interval a comma b. These 2 conditions are, first 2 conditions are same to the Rolle's theorem and Lagrange's mean value theorem. After that, third one, then they exist. Here third one, what is that? F of a equal to 0, then f dash equal to 0. Here third condition is different. That is, then there exists at one value of c belongs to a comma b, at least one value. Here a comma b is the open interval. In this open interval, c having at least one value can be satisfied. That condition, f dash of c equal to, you can write formula f of b minus f of a by b minus a. This is a formula. What is that formula? F dash of c is equal to f of b minus f of a all by b minus a. Here a is the lower limit, b is the upper limit. A is the minimum value, b is the maximum value of the interval. You can get all values. Here f dash of c is the derivative of f of x. F dash of c is what here? Derivative of f of x. You can write these all values in this f dash of c equal to f of b minus f of a by b minus a. F dash of c equal to f of b minus f of a by b minus a. You can write the a value. Interval is given here. In this problem, in this Lagrange's mean model problem, f of x function is given. F of x function is given and a comma b interval also be given. Suppose 0 comma 1 is given, then a equal to 0, b equal to 1. That a comma b value you can write in this function. F dash of c nothing but you can write f of x is given. That f of x you can derivative on both sides with respect to x you get f dash x. After that equation you can write in place of x c, you get f dash of c. Understood or not? In this way you can do that problem of the Lagrange's mean value theorem model problem. Here Rolle's theorem model problem also be similar than this one. Here Rolle's theorem is a problem is given. Here f of x is function is given, a comma b interval is given, interval is 0 comma 1 or 0 comma 2 or minus 1 comma anyone is given. That interval you have to take a value is the minimum, lower limit, b value is the upper limit. You can write those two values in this equation, the two are equal. F of a equal compulsory f of b. After that you can find the f dash of c equal to 0. F dash of c you can find which way? First f of x is given, you can derivative on both sides that function, you get the derivative on both sides, you get f dash in x. After that in that f dash x substituted x is equal to c, you get the f dash of c. That value you have to equal to 0, you get the c value. That c value belongs to in this Lagrange's mean value theorem and Rolle's theorem. This c value belongs to a comma b open interval. Here this c belongs to this c value belongs to a comma b open interval only satisfied, otherwise these two theorems cannot be satisfied. This is a very important point. This theorem, Lagrange's mean value theorem, the Rolle's theorem, both theorem statement you can read and write perfectly, you get 2 marks. 2 marks in the IP examination. Next class explain the Rolle's theorem, Lagrange's mean value theorem dependent problems.